Hello friends, welcome to Shiksharthi. In this video, we'll be talking about trigonometric identities in an interesting manner. So let's start. Now, at the very outset, I am assuming that you have gone through all my videos on trigonometry because whatever we are discussing today is based on them. So you're requested to go through all of the videos so that it becomes easier for you to relate with this. So starting off with, let today's learning experience also be a fantastic one. Yeah? Okay. So these are few things that I have picked up from my videos so that they can be referred to simultaneously. So one is this, which talks about different trigonometric ratios in different quadrants. The second talks about the 3x3 matrix that I had talked about in my video, which I feel is quite an innovative thing if you are able to understand, which I feel that you would have understood it by now. And the third is these trigonometric identities which were established based on the PBH concept. This is the PBH concept. Even here also you will see the PBH concept. Right? Okay, so we all are aware of this identity. What is the identity here? And for the sake of reference, I am taking a right angle triangle with the vertices as ABC. This is a right angle. The right angle is at B. If I take this angle as theta, which is angle C, in that case, angle A becomes 90 minus theta. The length of the line segment AB is P, which is the perpendicular. The length of the line segment BC is B, which is the base. And the length of the line segment AC is H, which is the hypotenuse. Okay, so we all are aware of this identity. Which identity are we talking about? We are talking about the identity sine square A plus cos square A is equal to 1, which we have already proved in one of our videos, though you can prove it again, right? Now based on this, the interesting part here is I can write, now this is sine square A. We all are aware of the fact that sine A into sine A can be written as sine square A. Similarly, cos A into cos A can be written as cos square A. And we know that 1 can be written as sine 90. We can write it as cos 0 also. But here we are taking it as sine 90. And very soon you'll realize why are we taking it as sine 90. Okay. Now, let this sine A remain as it is. So, now there are possible inferences that we are doing from here to make this very interesting. And all of these conclusions, inferences can be taken as logical conclusions. All of these. So, 1, 2, 3, 4, 5, all of them can be taken as logical conclusions coming out of this identity. The identity sine square A plus cos square A is equal to a 1. So now this sine A, I am bringing it down as it is, which is sine A. And then from this table, we know that in case if I talk about a right angle triangle, sine A can be written as cos C, which we have proved also. So this sine A, I am writing it as cos C. This cos A, I am maintaining as it is, right? This cos A, we know that I can write cos A as sin C from here or from here. So we know that cos A is equal to sin C. Once you have written this, now this identity gets transformed into a new one. And what is the new identity here? Now we know that angle A plus angle C is equal to 90 degrees. So instead of a 90 degrees, I am writing this as sine of A plus C. Right? Now, the moment I have written this, so we are able to establish a logical conclusion out of this, and the logical conclusion is sine of A plus C can be written as sine A cos C plus cos A sin C. This can be taken as a conclusive identity. And from where did we begin? We began from something that we had already known. Okay. Now, instead, taking it to a next level now. The next level is, instead of C, I am putting it as minus C. Now, when I put it as minus C, that means from here I can deduce another identity And another identity here is how much is sine of A minus C. So how much is sine of A minus C? You just need to put minus C instead of C. So this formula changes to, we know that sine of minus C is minus sine C, but cos of minus C is cos C. So in that case, sine of A minus C can be written as sine A cos C minus cos A sine C. Interesting? Okay. 3 more interesting things to be discussed here. So now coming down, so we know that sine A, I am maintaining sine A as it is, and I know that cos A is sine C. So this identity can be written as sine square A plus sine square C is equal to 1. Right? At the same time, now we know that sine A is cos C. So this sine square A can be written as cos square C. And at the same time, we know that cos A is, I can maintain this as it is. So this formula or this identity changes to another identity, which is cos square C plus cos square A is equal to 1. And this we are talking about with respect to a right angle triangle. And I hope by now we are sure of the fact that whenever we talk about trigonometric ratios, we start off with a right angle triangle only. Okay? The last fantastic experience is we are changing both. So what is the logic here? In these two, I had maintained one and changed the other. For example, here I had maintained sine square A and here I had maintained cos square A. But now in this final conclusive identity, I am changing the both. Okay, so when I change both, I know that sine A can be written as cos C, which is cos square C, because sine square A becomes cos square C, and cos square A can be written as sine square C, which becomes equal to 1. Hope you will be able to remember this and make a fantastic experience for yourself. So learning becomes exponential in nature only with the fantastic experience that we are trying to give to you. Yeah. If you feel that something very, very interesting has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you can start receiving updates from us regularly. If you want us to do some videos on some specific and difficult topics, please let it be known to us by putting it in the comment section. Thank you so much. Until next we meet, goodbye.